Hey everyone, in this video I want to go over what parallel and perpendicular lines are and how we can tell whether they're parallel or perpendicular on a graph. So let's go ahead and start with parallel lines. What exactly does it mean for a line to be parallel? So let's say we drew two lines, right? See, we drew a line from here to here, and we drew another line from here to here. And keep in mind, the reason why lines have arrows on either end is because you can extend these lines forever. You can extend these lines infinitely. So it doesn't have to stop there. The line could keep going on and on and on and on forever. And same thing with this line. This line can go on and on and on and on forever. And in the opposite direction, same thing. Let me put that back. You can also extend it the other way as well. Let me just delete that. Just that arrow. There we go. And let's extend it the other way too. Let me try to make it as straight as possible. And same thing with this line. We can just get rid of this part. And there we go. So what's special about these two lines? Well, these lines are actually parallel. And what makes them parallel is that they do not overlap. No overlap. These lines do not touch each other, as you can see, and they will never touch each other, no matter how much we extend them. It doesn't matter how much we extend this line, it will never touch the other line. And same thing with this line, it doesn't matter how far we extend it, it will never touch this line, no matter what. Now let me give you an example of some lines that aren't parallel. So let's say we had this line that went like this, and let's say we had this line that went like this. Now, although the lines are not touching right now, you see that they're not touching, these lines are actually not parallel. And they're not parallel because they do overlap when you extend them. So let's extend this line right here. So if I extend this a little bit, and then if I extend this line as well, put that back, if I extend this line as well just a little bit, you'll see that they do overlap. They do touch right here. So these lines are actually not parallel. So those are examples of parallel lines, and quickly let's talk about perpendicular lines. So what does it mean for two lines to be perpendicular? So let's give an example. Let's say we had a line that went like this, and another line that went straight left to right. It was flat. So these two lines are perpendicular. And what makes them perpendicular is that they overlap. So you can see that they're touching at this point, right here. And they form a 90-degree angle. So they form a 90-degree angle, also known as a right angle. So they form a right angle. In fact, they form 4 right angles, one on either side, here, 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 and here. So it forms right angles. That's what it means for a line to be perpendicular. It overlaps it in a way where it forms a right angle. And let me give you an example of a line that's not perpendicular. So if we had a line that overlapped in this way, you can see it does overlap. It does touch this other line at this point. But look at the angle at which it meets it. This angle is not 90 degrees. It seems to be a little less, maybe 70 degrees. And this angle is way too large to be 90 degrees. It could look like 110 degrees. So these are not perpendicular. So that's what it means for lines to be parallel and perpendicular. And now let's go ahead and see how they relate to equations on a graph. So let's erase all this. Now let's go ahead and draw a graph. So let's start with our y-axis right here, top to bottom, and our x-axis right here. And let's say we wanted to draw two equations. So let's draw y equals 2x plus 1. And then I'll also draw y equals 2x plus 2. Let me go ahead and label everything. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5, and -6. Going up, 1, 2, 3, 4, 5. Let's extend this a little more. Maybe we'll go up here. 5 and 6. -1, -2, -3, -4. Let's go down. So extend it maybe to -6, so -5 and -6. There's our graph. So let's go ahead and start plotting. So let's start with the orange equation, 2x plus 1. So this is already in y equals mx plus b format. We can go ahead and start with the b term plus 1. So 0, 1, that's our first point. And our slope is 2. So 2 over 1 is our slope right here. So we're going to rise 2 and go over by 1. So 1, 2, and over by 1. 1, 2, over by 1. 1, 2, and over by 1. And we can actually just label this real quick. That is 7 on the y-axis. Now let's go in reverse. So down 2, left 1. So down 2, left 1, down 2, left 1, down 2, left 1. There we go. We have our line. Let's go ahead and connect all the dots. Try to make it as straight as possible. Draw it as neat as we can. There we go. So that's our orange equation, y equals 2x plus 1. And let's go ahead and draw our blue equation, y equals 2x plus 2. So again, the b term right here is 2. So we'll start at 0, 2. And then same slope. Our slope is also 2 over 1. So we're going to go up 2 over 1, up 2 over 1, up 2 over 1. And that is actually, on the y-axis, that is an 8. So let's just extend that. That is an 8. And let's go the other way. So down 2, left 1. So down 2, left 1. Down 2, left 1. Down 2, left 1. Down 2, left. Okay, so that's down 2, left 1. Let's do one more point. Down 2, left 1. Okay, that should be enough. Let's go ahead and connect all these points together. Let's try to draw it as neatly as we can. Okay, so we have two lines. In blue, we have y equals 2x plus 2. And in orange, we have y equals 2x plus 1. So what can we tell about these lines? Well, these lines seem to be parallel. It looks like, just from looking at these lines on the graph, no matter how far we extend them, they will never actually touch each other. Now, how can we tell that the lines are parallel? Well, notice that they have the same slope. They both have a slope of 2. Their m is equal to 2. So the rule is, two lines are parallel if they have the same slope. If slope is the same. is the same. So let me just rewrite that. So if both slopes are the same, then it's parallel. And that's the golden rule. Two lines are parallel to each other if their slopes are the same. So just another quick example, if we had two lines, without even graphing these equations, if we had y equals 4x plus 3 and y equals 4x minus 2, right away, before even graphing them, we know that they are parallel. Why? Because they have the same slope right here, 4 and 4. So right away, we know that both of these are parallel without even having to graph them. And if we did graph them, then we could see for ourselves visually that they are parallel. Perfect. So now let's give an example of graphing perpendicular lines. So let me actually delete the blue one right here, this blue equation. And let's delete the blue line. Let's put that back. Just get rid of that blue dot. Just the blue dot. Can I just get rid of the blue? Excellent. Okay, so we'll keep the orange equation, y equals 2x plus 1. And now we're going to graph a line that is perpendicular to it. So it is y equals negative 1 over 2x plus 2. Okay, so let's go ahead and graph it, and let me actually make it a different color. So let's make this one green. Y equals negative 1 over 2x plus 2. Okay, so let's start graphing. So our b term is 2, positive 2, so we'll start at 0, comma 2 right here. And our rise over run is negative 1 over 2. So that means we're going to go down 1 and over 2. So down 1 and over 2. Down 1 and over 2. Down 1 and over 2. And on the x-axis, that gets us to 6. Just go a little bit to the right. So we could draw that 6. There we go. Okay, and then let's go in reverse. So what's the opposite of that? That's up 1 and left 2. So up 1 and left 2. And let's actually get rid of... We can move this golden rule for what it takes to be parallel. 1 second. Put it right here. Let's go back. So up 1 and left 2. So up 1 and left 2. Up 1 and left 2. Up 1 and left 2. Good. And let's go ahead and connect the points with a line. Perfect. So we have two equations graphed here. In orange, we have y equals 2x plus 1. And in green, we have y equals negative 1 over 2x plus 2. So they do overlap at this point right here. And you could probably tell just by looking at it, it looks perpendicular because it does form a right angle right here. And on all four sides as well. So it looks like it's perpendicular, but how do we know? So it's all about the slope. Take a look at their slopes. So in the orange, the slope is 2. And in the green equation, the slope is negative 1 over 2. So this is the rule for perpendicular lines. Two lines are perpendicular if the slope is, and this is a key word, negative, it's the negative reciprocal. So negative reciprocal. The negative reciprocal. So that's the rule for perpendicular lines. Two lines are perpendicular if the slopes are negative reciprocals of each other. Now, what exactly does that mean? Well, in this first one right here, the slope is 2. Our m is 2 in this case. And in the green equation, our slope is negative 1 over 2. So how do I get from 2 to negative 1 over 2? First, you take the reciprocal, and then you flip the sign. So just as an example, let's say we had a slope of 5. Let's just do a few exercises right here. 5. What's the negative reciprocal of this? Well, this is really 5 over 1. And the reciprocal means you flip the numerator and denominator. So this becomes 1 over 5. And then you take the negative of that. So this becomes negative 1 over 5. Let's do another example together. Let's say we had negative 3 over 2. So again, the negative reciprocal. What's the reciprocal of 3 over 2? If we flip the numerator and denominator, that is 2 over 3. So negative 2 over 3. And we're taking the negative of a negative. So we're taking the negative of a negative. So a negative makes a positive. So negative 3 over 2, the negative reciprocal, it becomes positive 2 over 3 right here. And we'll do one more example together. Let's say we had negative 2 over 5. So the negative reciprocal, again, you just flip the numerator and denominator, so negative 5 over 2. And we have a negative, so the negative becomes a positive 5 over 2. So you flip the sign. If you started with a negative, you flip it to a positive. If you start with a positive, you flip to a negative. You just flip the sign. And then you flip the sign, and then you flip the numerator and denominator. And if it's a whole number, like in this 5 example right here, if it's just 5, then you treat it as 5 over 1. And then you flip it to 1 over 5. So that's how you find a negative reciprocal. And the rule is that any two lines, if their slopes are negative reciprocals of each other, then they are perpendicular. And just to go through another example, let's say we had these two lines. So let's say we had y equals 5 over 2x plus 3, and y equals negative 2 over 5x plus 2. So take a look at their slopes. These are negative reciprocals of each other. The negative reciprocal of 5 over 2 is negative 2 over 5. Therefore, these two lines are perpendicular. They are perpendicular to each other. So that's how you can tell if any two lines are parallel or perpendicular on a graph and by their equations. I really hope this video helps, and please let me know if you have any questions down in the comments below. Thank you for watching.